One is on the National Geographic ship, the Endeavour. That's going to be in October to the Galapagos. And we're going to have Jim Masterson, who is the head of the Ocean Discovery Center, going with that group. So there'll be a Harbor Branch scientist that will be participating. And then I'll also tell you about a second opportunity that'll be in 2011 in Antarctica. And lastly, I want to mention that we got information for the Smithsonian Marine Science Lecture Series, and they have a talk next Thursday, the 18th at 7 p.m. There's flyers out in the gallery. It's at the Pelican Yacht Club, so it's not here. It's down in Fort Pierce, Pelican Yacht Club. I can tell you where that is if you need to know. It's by the director of the Smithsonian National Museum of Natural History. So coming from Washington, I hope I hope you can get out. Hope the snow stops by then. So maybe this will change. But it's going to be on new waves of ocean science at the Smithsonian. Again, he's the head of the Natural History Museum. So if you've ever gone to the mall, D.C., you've been to his museum. And a lot of folks in Fort Pierce, they work here, but under affiliation there. And he's going to talk about some of their programs that they're doing, including the Ocean Science Hall. If you ever get a chance to go to Smithsonian to see the Ocean Science Hall, you got to do that. It's right here. Okay, that's all my advertisement. Now, it's my pleasure to introduce tonight's speaker. Many of you know Dr. HBOIlaPoint. He gives wonderful lectures. So many of you have heard him in the past. And his work is well known on the decline of coral reefs and also its causes. Brian started working at Harbor Branch actually as a Woods Hole Oceanographic Institution employee 35 years ago, working for Dr. John Ryder. And Brian actually started out as a brand new graduate, undergraduate in Boston, working with John Ryder at Woods Hole in Massachusetts as a technician. And then in 1974, they moved the project to Harbor Branch. Brian went back to school a couple years later. He got his master's in environmental engineering from the University of Florida and his PhD from the University of South Florida. And then he came back to Harbor Branch in 1982, and he's currently a research professor in our Center for Marine Ecosystem Health. Now, when Brian came back, he actually came back and started living in the Keys and working in the Keys. So he's lived and worked in the Keys for 28 years. And tonight, you're going to get really a nice, interesting mixture, I think, of information about the Keys, some of the things that have happened in the past, and some of the things that have happened in the past and present with coral reefs. So you're in for a real treat. It's always a great pleasure to introduce my good colleague, Dr. HBOIlaPoint, who will speak on reefs, wreckers, and shipwreckers in the Florida Keys.
Well, good evening, and thank you all, and I mean all of you. It's a great turnout tonight for coming out to hear the lecture and seeing all we do here at Harbor Branch and FAU. I am going to talk about Florida Keys tonight. It's a great night to talk about that. It's still relatively warm down there, and it's one of my favorite subjects, something I never get tired of talking about. In the past couple of years, I've talked about a lot of the detailed research we've been involved with down there over the past 28 years. Some of you probably remember Corals at the Crossroads. You can still access that documentary film that we made for the Research Channel on YouTube. But anyway, tonight I'm going to do something a little different, as is evident in the title. I'm going to step back from the science a little bit and look at a broader view of the reefs in the Florida Keys. And in particular, look at how the human perspective towards these reefs has changed over the centuries, particularly in the last several decades, as water quality and reef health have taken quite a toll. So with that, and I'm going to finish up the talk tonight explaining a little bit about the work we're currently engaged in a grant from NASA. And this is allowing us to study the health of these coastal waters around the Keys from space. So the interesting part of this work is we're really doing rocket science now here at Harbor Branch. Couldn't say that before. So the talk tonight is also historic. It's going to be a lot of history about the Florida Keys. And we got to start with the beginning here and ask the question, what is a reef? What are we really talking about? The primary definition, if you look this up, is a narrow ridge of rocks or sand, often of coral debris, at or near the surface of the water. And that's pretty much what I'll be talking about, particularly the coral debris, preferably living coral cover. But there's a secondary definition in mining that refers to a lode or vein, as in gold. And so I am going to be also incorporating some of that definition. We're going to talk about some of the gold and silver that has actually formed reefs in the Florida Keys, as in the Bank of Spain. And the third definition I'm going to talk a little bit about, and this is all kind of related, is the nautical definition. That's the part of the sail which is rolled and tied down to reduce the area exposed to the wind. And that has meaning because of those Spanish sailors back in the 1600s that left Havana Harbor to go back to Spain, loaded with silver and gold and bullion and emeralds, only to within 24 hours sail into a hurricane and be blown towards the reefs of the Keys. Of course, they were reefing those sails down as that storm approached, but it wasn't enough. The mast snapped and they ended up moving over the reefs and sinking. And we'll hear more about that in the talk. Of course, there are other definitions of reefs, a few others, and those that reef called reefers. And I'm not going to talk about reefers tonight. That's in another lecture. But that's a big story of the Florida Keys. So the reefs I will be talking about include the coral reefs of the Florida Keys. This particular photo of this coral reef depicts elkhorn coral, which is arguably the giant redwood of the Florida Keys. It is the hermatypic or reef-forming coral that forms the framework of the reefs we go dive on today in the Florida Keys. Problem is, as you'll see tonight, we have lost 98% of this very important keystone species on the reefs of the Florida Keys, pretty much over the last 3 decades. That particular photo was shot in the Abacos in the Bahamas near Green Turtle Key, not in the Florida Keys. There is still a little bit left today. Next to that, the top right photo is a picture of another type of reef we refer to as floating reefs. That's the brown seaweed sargassum, that when you go out to the reef to dive or fish and you go offshore of the reef, this is where you go obviously to fish for mahi. These weed lines act as fish aggregating devices, and about 100 organisms actually are endemic to this floating seaweed community. And it's actually very important to the reefs, the coral reefs of the Keys. It connects them with other coral reefs around the Caribbean region. And in terms of recruitment to the reefs of the Keys, it's a very important mechanism bringing larvae into that region. Bottom left, of course, the gold bars, we're going to be looking at some reefs. And the bottom right panel here are artificial reefs. Really, the story is a lot about natural reefs versus artificial reefs and how things have changed over recent decades. Now, the Florida Keys, when you go down there, you drive down from the mainland, you drive through the 18-mile stretch, over the new bridge at Jewfish Creek, and you come into Key Largo. And at that point, you're actually riding on top of a fossil reef. The geologic formation is called Key Largo limestone. Florida Keys really are a land made from the sea. This limestone, if you actually look carefully at the Marvin Adams Waterway on Key Largo, you can actually see these fossil corals. This particular specimen is about 6 or 7 feet tall. It is a fossil of one of the major reef-forming corals, Montastria angularis. It's about 100,000 years old, this formation. And that Key Largo limestone extends down to the lower Keys, down to Big Pine Key, where it meets the other significant formation, Miami oolite, which are small little carbonate particles that are cemented together and kind of looks like concrete. Not as interesting as the fossil reef formation of the Key Largo limestone. But the geology of the Keys played a very important part of our septic tank study back in the 1980s when we were looking at what septic tanks were doing to water quality. And as it turns out, our studies with a flow meter showed that the Key Largo limestone was much more porous than the Miami oolite. On average, we had about 10-fold higher flow rates of septic plumes moving through that formation out to the reef. So this was a very important part of the science that ultimately led to sewering Key Largo. And that sewage system is just about done now, by the way. And the rest of the Keys are in the process of sewering themselves as well. Well, the wrecking era, I think many of you are familiar with this term. It's a very kind of colorful part of the history of the Florida Keys. And it dates back at least 500 years ago when the Calusa Indians that lived up and down the Florida Keys would paddle out in their canoes. Increasingly, as early explorers would run aground on the reefs, the Indians would go out and harass the explorers, especially the Spaniards. They didn't get along too well. And that, of course, over the years, more and more of these explorers and many of the Spanish ships, the treasure fleets, would run into those hurricanes, sink around the reefs of the Keys, and eventually the Spaniards themselves would come back to these sites to salvage, again, the Bank of Spain that was laying on the bottom around the reefs of the Florida Keys. And this continued. A lot of merchant mariners in the 1800s in particular were running aground, and this is really when the wrecking era came into its heyday, when Bahamians, many from Green Turtle Key, came to Key West at a time when Key West was one of the most prosperous cities in the United States. Per capita income was the highest in the US. Florida's first millionaire, William Curry, was 18 years old when he made the trip from Green Turtle to Key West. You can see his house today, the Curry Mansion on Caroline Street. He ran a ship's chandlery, a very successful business as a wrecker. And with all the money being lost to the wreckers and insurance companies and shipping agents that were losing money, there was a plea for the federal government to do something about this industry, to kind of clean it up and make the passage safer around the Keys. And that's when the lighthouses went in, around the 1860s or so. And this is the Carey's Fort light. It's an example of one of those lights that still remain today. Well, the same period of time, the federal government was hearing these pleas to do something about these dangerous coral reefs in the Florida Keys. And they were really asked to try to do what they can to get rid of the reefs. And the superintendent of the Coast Survey at that time, and this is the predecessor of NOAA, the agency that oversees, has federal jurisdiction over these waters today, commissioned Louis Agassiz, the very famous Swiss naturalist from Harvard, to go down to the Florida Keys and see what could be done about killing the coral, getting rid of it. I mean, it's bizarre today to think that they were really thinking in those terms, but they were. Louis Agassiz went down there and just could not believe all this prolific coral everywhere, and he wrote back to the superintendent and told him, as you can read, he could not see any possibility of stopping the growth of these coral reefs beyond the bounds which nature itself has assigned to their growth. Well, that was 1851. We had figured out how to make that coral stop growing. We're going to talk about some of those details. During this period, one of the ships that ran aground at one of my favorite spots in Florida, Looe Key, was the HMS Looe, a British frigate carrying 44 guns, ran aground in the middle of the night on February 5th, 1744. This has special interest to me and a lot of us at Harbor Ranch because the salvage of the HMS Lou and recovering a lot of the artifacts off it was conducted in an expedition in around 1951 by Mendel Peterson of the Smithsonian Institution, curator of the Naval Museum there. And who he worked with was someone very close to all of us here at Harbor Ranch, Edwin Link, designer of the Link trainer and the Johnson Sea Link submersibles. And I love this picture. It comes out of Mendel Peterson's publication of Ed Link up on the mast, rigging a block and tackle to raise a 1-ton iron cannon off the reef at Lou Key. It's part of this salvage operation. Now look at the size of the boat, Ed. That's a small little yawl built with a hull of mahogany, okay? Well, he raised it very easily with a block and tackle around the main boom and laid it alongside the hull with bumpers and fenders to protect that mahogany, sailed it back into Marathon, where it became part of the recovery of the remains of the HMS Lou. That's the kind of guy Ed Link was, though, a real engineering genius. And it's great to look back at the wonderful expeditions that Ed was involved with the Smithsonian Institution back in the day. Well, it was a few years later that Ed founded and developed Linkport, right where we are located tonight. And this is about the time I arrived, 1974. It looked a lot different back then. This is the entrance you just came through. And you notice the big letters Linkport, Harbor Branch Foundation Lab, or these little letters over here. And if you go down, the Smithsonian Institution was on the property, Sea Diver Corporation, the Diver Training Academy. And at that time, I came from Woods Hole to construct and develop a wastewater treating aquaculture system in which we took the sewage from the treatment plant here at Harbor Branch, and we basically used that sewage to feed a marine aquaculture system comprised of algae ponds, both phytoplankton and seaweeds, that remove the nutrients from the sewage. And the effluent coming out of the end of the system was actually lower in nutrients than the water coming in from the Indian River Lagoon that we were mixing with the sewage. Another vision before its time, okay? But this is where the whole aquaculture program actually began, right here at this little site, which we call Aquaculture North, is where it all began. Picture over here of Ed Link in this time frame with Roger Cook, the director of the Marine Operations Program, next to the Johnson Sea Link. Also a shot of the early 1970s here at Linkport. Well, those were very interesting years here. A number of characters were working here with Ed and other scientists at Linkport. And one of the more interesting guys was Fay Field, shown here. Fay was working with Ed to develop the magnetometer, ultimately the proton magnetometer. That was a key piece of innovative technology that was used ultimately to find the Etosha and the Margarita in the Florida Keys. But at this time, in the 60s, Mel Fisher was living here in Vero Beach, working the 1715 wrecks here off this coast. But the other interesting thing, Mel and Ed and Fay, of course, were all talking about ocean engineering technology that needed to be developed to find the gold, the treasure sitting down around the reefs of the Keys. And the other thing that Fay came up with is what's known as mailboxes. And these are these devices that are used to divert the prop wash from the treasure salvers vessels, all tied up here, to take that prop wash and divert it downwards to the sandy reef below, where the divers are busy down there looking to pick up the gold. One of the problems was where the number of days the divers could work, because storms would churn up those bottom sediments and create a lot of turbidity. So the idea was to get the surface water, which was clearer, down to the bottom, create like a bubble of clear water down there. But what they also realized was the force of that water would act as a duster and dust the sand away gently, exposing, of course, the gold that they could then pick up in their hands. And that was a major tool that was used very successfully to, as I said, eventually locate the ballast pile in Mother Lode. This is a photo that actually was just sent to me by a friend in Key West. He knew I was giving this presentation tonight. And Don Kincaid, who worked with treasure salvers in Key West in the early years in Key West. This is 1972, a shot of Mel Fisher, Fay Fields, and Ed Link standing here at the dock in Key West next to the Johnson Sea Link. And I moved down to the Keys to begin our field station and all the research we've been involved with in July of 1982. It was just about 3 years later, I'll never forget that day when they found the Mother Lode on the Etosha. Here's Mel, Kim, Kane Fisher, here are the mailboxes behind. And on the right panel, I know it's very hard to see these photographs, but the bottom panel here are the big 70-pound silver bars. I was going to bring some of these in for y'all to see tonight, but they're a little too heavy to bring. But I wanted to make the point that these silver bars, when they found the ballast pile of the Etosha, they were literally a reef on the bottom, 3 feet high, stacked like cordwood, covered with lobsters. It was just before lobster season. And of course the divers just pushed the lobsters away to get the silver bars off the bottom. But that's an example of a treasure reef, I think the kind we'd all like to find. Well, about the same time frame, it was becoming evident to a lot of people that the reefs were becoming under siege from human activities. A variety of problems. One major problem was the harvesting of coral. At that time was legal to go out and pull coral up off the reef and sell it in souvenir shops. And there were shops from Melbourne to Key West selling this stuff to tourists as a souvenir to Florida. And this is a photo actually from the Florida Keys in that time period. This is all staghorn coral on the back, and we had some conch shells and other types of shells on the front of this barge. So this, I think, was clear that the hands of man, so to speak, were at work on these reefs, and it wasn't a good thing for the reefs. So we began to see this trend of establishing marine protected areas, starting with John Pennekamp State Park in 1960. The state of Florida had a lot of concerns about overdevelopment of the Florida Keys, sewage, stormwater runoff, creating, impaired water quality that would affect the reefs. So that was 1974. That meant that the governing cabinet had the ability to review all the major development permits that were going to be issued for the Florida Keys. 1975, Key Largo National Marine Sanctuary was set up. 1981, Lou Key. Both these were fairly small sanctuaries. 1990, the federal government, NOAA, figured out we really need to have a big sanctuary and extended sanctuary status from Key Largo all the way out to the Dry Tortugas, approximately 2,800 square miles. About the same time frame, 60s and 70s, of course, the population was booming in South Florida. We were seeing a lot of urban growth in Southeast Florida, a lot of agriculture expansion, particularly sugarcane, following the Cuban Revolution. Part of that economic embargo, as I think many of you know, involves price supports of sugarcane. It was expanding, and as part of that operation, of course, they had to drain the 750,000 acres of the Everglades Ag area to expose this nitrogen-rich black muck, to dry it out, to allow the farmers to farm it. And to do that, they had to either back pump into Lake Okeechobee or send that water to the east through the canals to the Lake Worth, Lagoon area, St. Lucie Canal to the east, or the Caloosahatchee to the west. Wherever that water go or went, it caused problems. And it was Art Marshall who was the first person to really recognize the problem of what was going on at this time, how it was causing algal blooms and eutrophication in Lake Okeechobee. The water managers at the time, of course, it was called the flood control district because their main issue was moving water, okay, preventing floods and also providing water for potable water supply. So they weren't really thinking about the quality of the water, and it was Art Marshall who saw that this muck and the nutrients and other contaminants coming with it was a real problem. Art was the first to realize that water quality is a far graver problem in the long run than is water quantity. And that had special meaning for the Florida Bay, Florida Keys region down here, because these water managers were realizing that they really were wanting to put more and more of the excess water from Lake Okeechobee southwards towards the Everglades, not just to give the Everglades more water, but to not put it up in these other areas where it was causing these obvious environmental problems. The other interesting thing about Art was located right here in Vero Beach. He was the director of the U.S. Bureau of Sport Fisheries, which then became the U.S. Fish and Wildlife Lab that is still right here in Vero Beach. So, if we fast forward now to 1990, the new Florida Keys National Marine Sanctuary has been set up. It was the first sanctuary in the U.S. to have a water quality protection program because of the obvious water quality problems that we were having in Florida Bay. As more of that water came south through the Everglades, nitrogen was actually coming through the Everglades. It wasn't being removed by the river of grass. And it was feeding algae blooms, particularly on the western side of Florida Bay, where Shark River Slough delivers most of that water and nitrogen. These are the tidal passes of the Florida Keys. Okay, coming, you can see the green water streaming through in the 1990s as more and more water was coming into the bay. Now, the interesting thing is, at the time, we knew this was a problem, land-based nutrient runoff. However, that was not politically correct. We were in the midst of the Everglades lawsuit, which only recognized phosphorus as a problem up in the Everglades, and it was causing the cattails to expand. Nobody wanted to believe that nitrogen was actually getting all the way through the Everglades into Florida Bay. So the sanctuary process came up with their own theory as to explain what was causing these algae blooms that were affecting the corals on the reefs in the downstream areas. And their idea was that this was simply a problem of the water being too salty. And their solution was to just bring more of that water down from Lake Okeechobee into Florida Bay. It sounds like a good idea, huh? And that's what they did. I don't know what really they were thinking, but this is Shark River Slough. Okay, this is one of the two major rivers in southwest Florida. There's Shark River and there's the Caloosahatchee. And this is where they can put a lot of excess water from Lake Okeechobee. As you can see, it comes out through a mangrove fringe into the western side of Florida Bay, which is just down this way. It delivers a lot of nitrogen. Okay, 1 million acre-feet or more of water can come down that slough in a year, delivering tons and tons of nitrogen. Well, between 1991 and 1996, when they ramped up the flows of water, the algal blooms that were being created were so large, we really knew we needed to use satellites to monitor the scale of these algal blooms. So this is one of our early satellite images. It's a Landsat satellite image. It's enhanced to show this discolored water in the western Florida Bay. This is Cape Sable, Long Key down here. And the currents are carrying this algae bloom and turbidity down towards the Channel 5 bridge in the Florida Keys. And a lot of this water mass is also moving down towards the lower Keys. Another satellite image a few years later. This was at the peak of the flows and the nitrogen loads coming down from the Everglades. This particular kind of satellite image it's an AVHRR image, and what we're looking at, this red color, is where we have the maximum reflected light coming back up to the satellite. It's from dirty water. It's from turbidity and algae blooms in the water reflecting light back up. This bluer color is clear, optically clear water where the light is penetrating into the water, very low reflectance. So you can see where this water is coming out of Shark River Slough right here above Cape Sable. It's creating all this dirty water on the Gulf side of the Florida Keys. You can see a lot of this water is coming through the tidal channels to the outer reefs, and it really extends all the way out here, the Marquesas, where the Atosha and Mel Fisher's operation is happening, and it actually extends all the way out to Dry Tortugas. But you can see how the Florida Keys are like a dam holding a lot of that water up in what we call the backcountry of the Keys. This is what the water actually looked like in that time frame. Very green, very turbid water. Very little light can penetrate through that water. So we saw a lot of seagrass die off in the western side of Florida Bay, and coral die off, okay? This is a photo I took of the rock pile. This is a reef down in southern Florida Bay near the Content Keys. This is a beautiful reef about the size of a football field, comprised of brain corals that many of these were 6 or 7 feet tall, hundreds of years old. Really an incredible area. It was one of the best places to go diving for lobster. And that's one reason we used to go out there a lot. But we also went out to collect algae in the 80s because we saw this green filamentous algae begin to form blooms in the summertime, clearly indicating to us that there was a nutrient problem in the 80s that was developing, not a severe one, but something was becoming enriched in terms of nutrients. Well, after the flooding of Florida Bay, the water was so dirty for about 10 years we really couldn't even dive the rock pile until around 1998, 10 years later. The water cleared up, and when we went out to the rock pile, this is what we found. All those brain corals were basically dead and covered with indicator species of excess nutrients. These red and orange sponges, and this bubbly little algae. This is a species of Caulerpa racemosa. And basically we kept an eye on those dead heads over the years, and the most recent photos here in 2008 is another species of green algae. This is Cladophora liniformis, another well-known nutrient indicator species. So you have to realize between this time frame, these reefs that had been there, these corals for hundreds of years, vanished in the wink of an eye on a geologic time scale. So obviously they didn't survive the restoration plan that the sanctuary officials had hoped for. In 1996, again at the peak of these water flows and nutrient loads from the Everglades, we saw extensive blooms of cyanobacteria, and that's what I'm holding up here. This is a genus Lingbia. This has a lot of very nasty chemical compounds, things like Lingbia toxin that some have linked to fibropapilloma in sea turtles. And we have a lot of other cyanobacteria algae also blooming in Florida Bay. All of these produce some nasty compounds, others which have been linked to ALS and Alzheimer's in humans. So it's not just an environmental issue, there are human health issues here as well. Concerns about uptake of these in the food web of the Florida Keys, the shrimp, the lobster, the seafood. Well, the water didn't just stay in Florida Bay. Obviously, as you saw in the satellite images, it's coming through the tidal passes. This is the 7-mile bridge. You can see this kind of dark water, what some have referred to as black water, coming out towards the outer reef in the Keys. And obviously this has the ability to go all the way offshore, about 4 miles, to the Outer Bank reefs, such as Luke Key that we see here. And Luke Key is where we kind of realized early on this would be a great place for our long-term nutrient monitoring study in the Florida Keys. And we began this monitoring program in the early 80s, around 1984. And the one science slide, real data slide I'm going to show tonight, I'm going to put up now to show the kind of data we have been collecting. It's the longest term record of nutrients for coral reef anywhere in the world. And it's something that we're continuing today. What I've done is I've averaged all these different numbers that we measure, things like chlorophyll A, which is algae in the water, phytoplankton, single-celled algae, ammonium, a nutrient, a key nutrient, making algae grow, nitrate. We add up ammonium and nitrate to give us dissolved inorganic nitrogen here. And then at the end, these yellow bars are soluble reactive phosphorus. Mainly nitrogen, phosphorus, and chlorophyll is what we're monitoring. And I've averaged these. These are the numbers of samples, the numbers in the bars here, decade by decade for the 80s, the 90s, and from 2000 on. And what we see very, very clearly is that the water quality at Luke Key is directly controlled by the flows coming out of Shark River Slough, okay? That is a major nitrogen source, providing nitrogen that makes the blooms in the Florida Bay system either grow when that water comes in or contract when the flows subside. And we see that because in the 80s we had relatively low flows, less than 500,000 acre-feet a year. The 90s we had on average over 1 million acre-feet a year. And in the years since 2000 we've been down to about 600,000 acre-feet a year. So by decade it's low, high, and medium flows from the Everglades. And you can see how the chlorophyll matches that temporal pattern and flows. So in terms of water quality, we call the 80s a good decade for water quality. In a relative sense, then the reef was still in pretty good shape then at Luke Key. Since 2000, it's kind of been bad. Even though the flows have subsided, the chlorophyll has not come back down to what it was in the 80s. So the water is tainted a bit. It's not quite what it used to be, and of course, all the divers know that. The 90s, however, when they put all that water in Florida Bay, was really ugly. That's when we lost a lot of living coral on the outer reefs, and it wasn't just at Luke Key, it was sanctuary-wide. But the situation we're in now is that we're now averaging nitrogen and phosphorus concentrations over the tipping point of 1 micromolar for nitrogen and 0.1 micromolar for phosphorus. Okay, the nitrogen went over that tipping point in the 90s because of all the nitrogen coming out of the Everglades. The phosphorus has gone up decade by decade, and so if you actually look at the nitrogen-phosphorus ratio, it got tweaked in the 90s. It actually went up because of all the nitrogen-rich runoff from the Everglades. So it's this kind of model that has now been embraced by EPA and the Florida Department of Environmental Protection, the idea of setting numerical nutrient standards and trying to control water quality to prevent these kinds of problems from happening is going on right now. It just started last year as a result of litigation in 2008 that was started by a group called Earth Justice and the Sierra Club. So we're very engaged in this process. They're using a lot of the data we have generated over the years to try to get these nutrients back down to what they were in the 80s, so we can get some recovery of water quality in our coastal systems. Now, as all this was happening in the Keys in the 90s, with all these excess flows of water coming in from Lake Okeechobee, this is what the headlines look like every couple days. The blanket of algae smothers the reef. Not just non-toxic algae like seaweeds that we work with a lot, but toxic, harmful algal blooms, red tides, huge red tides that were killing a lot of big fish, tarpon, sea turtles, bonefish, the worst fish kills people could remember in the Florida Keys. Also bacteria. The beaches from Key West to Key Largo were being shut down because sampling by the state and county was showing that they were failing the fecal coliform standards for the state of Florida for safe swimming. So obviously, you know, if you're a tourist and you're going to Key West and you can't swim on the beach, you know, you're not going to stay around. It was an economic crisis, and this problem extended all the way out to the Tortugas, the whole region. And the problem is it's all connected. When you create a big algae bloom like that, you're creating organic matter. That algae dies, the bacteria feed on the organic matter, and they grow. And it's not just a human health issue. What we learned from this is that one of these fecal coliform bacteria is Serratia marrescens. It's this little bug here. And this was identified by Dr. Jim Porter at University of Georgia, who's been monitoring coral in the Keys. This is the little bug that has been killing the elkhorn coral of the Florida Keys, what's known as white pox disease, okay? It caused essentially a mass extinction of elkhorn coral in the 90s. Now, I'm going to take you through some of the coral monitoring photo quadrats just to show you how this happened in the 90s. This is the elkhorn coral on the reefs of the Keys. This brown tissue is living coral. This is July of '94. Watch as we run through this. Here we are, October '96. You see that white pox disease spreading over the living tissue. Here we are in '98, very little living tissue left. By December 2000, essentially all the coral, living coral tissue is gone. That's an algal reef we're looking at. That's just algal turf on that dead coral skeleton. This happened not just on this reef in Key West. 98% of elkhorn coral of the Keys died off. The main coral, okay, that geologically has built those reefs. So today when you drive to the Keys, it's not just on Big Pine Key where you run into the endangered key deer, where we have endangered and threatened species. Virtually the entire overseas highway, when you're looking out over the ocean, those two species of coral, elkhorn and staghorn coral, are now on the endangered and threatened species list because of this problem. Okay, at this point, I'd like to show you a little video clip to really give you a better idea of the habitat that has been lost in losing, again, what we consider to be the giant redwood of the Florida reefs. Okay, Jill, if we could, yeah. Here we are, Lou Key. First time we began using video in our research in the 80s, 1988. This is what the forests of elkhorn coral look like for centuries. Thousands of years, this coral flourished and dominated those reefs of the Florida Keys. I want you to look at how this coral grows up into the water column, providing three-dimensional habitat for these fishes we're looking at. These are copper sweepers. See a stoplight parrotfish, that redfish, and just masses of snappers and grunts. These are Bermuda chub. Look at that blue water. That blue water has very low chlorophyll nutrients in it, okay, from the 1980s. And as we swim across the coral spurs at Lou Key, you can look at these soft corals now and sea fans. There's no disease on them, no epiphytic algae like we have seen in the 1990s and since. Okay, a brain coral. Okay, this is the same type of coral that we saw die at the rock pile, okay, in the Florida Bay side of Big Pine Key. Once again, you see all living tissue, very healthy looking coral, no disease or necrosis. And Lou Key is such an amazing place. You never know what you're going to run into out there. A couple of snook coming through the coral formations. Okay, so here we are in the 1980s. What I'm going to do now is fast forward with you to the year 2000. Okay? This is one of my students running out of transect tape, and what you're looking at here are dead skeletons of the elkhorn coral. Again, no living tissue left, okay? And again, the main mechanism of die-off was that white pox disease, a fecal coliform bacterium. You can see some of the other types of organisms that can still survive down here. There's a little fire coral that can still grow. Some other corals that are a little more hardy than the elkhorn and staghorn corals that are still surviving. And of course, some of these soft corals are still surviving as well. And what's interesting, if you look down close at the reef, you do see a lot of macroalgae, okay, as we see here. But even though we've lost all this reef habitat, we've seen snappers, groupers, and grunts die off, but these are parrotfish, herbivorous fish, that have actually increased as we've lost this coral because they feed on algae. They're herbivorous, okay? But we've seen a dramatic decline in snappers, groupers, and grunts in a marine protected area where there's no fishing. So it's not all about overfishing. We're talking about habitat loss here at Looe Key. Well, there are some efforts made to try to get these reefs in recovery. Some of the stimulus money is going to the Nature Conservancy, who interestingly was part of the proponents to flood Florida Bay. They were very much involved in the early days of trying to get the Army Corps of Engineers in the district to put that water down there. But now they're getting $3.3 million to transplant some of these remaining acroporids in nurseries, both in the Florida Keys and the Virgin Islands. $3.3 million for 1 acre of coral that they're going to try to create through these nurseries. And I know they're doing some of this work off Key Largo in the Florida Keys, out on the outer reef. So you'll want to kind of, if you're interested in this, you'll want to kind of keep an eye on the success of those projects. Obviously, this has not been good news for the economy of Monroe County, as the mayor points out. When the coral shrinks, the economy sinks. So now we find ourselves in a situation where the tables have turned when we look back at the history of the Florida Keys. You remember in the days of old, the reefs were a threat to ships that were sinking on the reefs, and we wanted to kill the coral. Now we find ourselves in a situation where we're actually paying a lot of money to deliberately sink ships, to try to attract divers and to create artificial reefs. Okay, these are just 4 of many artificial reefs that have been sunk in the past several decades. One of the more recent ones, the Spiegel Grove, went down in 2002. It's 510 feet long. Maybe you remember it got international media attention when it went down sideways and looked like a real problem for the project managers that were overseeing this operation. But only for 3 years later, after it was sunk, Hurricane Dennis in 2005 actually righted this ship on the bottom. Bottom currents and surges turned it upright. So if you go there today, it won't look like what you're looking at in this photo. It's upright. The most recent one of these projects is the Vandenberg project in Key West. Now, the divers in Key West wanted a bigger ship than Key Largo had. So the Vandenberg is 520 feet long, 10 feet longer than the Spiegel Grove. And like the rest of the ships that have been sunk, you know, this has been proposed to create habitat to strengthen the reef ecosystems in the Keys. Again, you saw that elkhorn coral, all that habitat that's been lost, improve the fishery, relieve pressure on the natural reef. Also to develop recreational attraction for diving, snorkeling, and fishing, and provide opportunities for education and research, and of course, preserve history. Magnificent troop transport ship, a lot of rich history. So now like to ask you, how many of you have been down to dive the Vandenberg? All right, one person, fantastic, great. I know the rest of you may not get down there, so tonight I brought the Vandenberg here to you. We're going to show a little video clip now of the sinking of the Vandenberg and some of the survey work we've done, because there are a lot of signs here.
Built of steel back in 44. Her fate at birth to haul our troops to distant shores. All the brave souls who walked upon her deck, we shall always promise never to forget. The mighty ship Vandenberg, she sailed all the oceans of the world. 500 feet of history making way. They're sinking the Vandenberg today.
Joe Weatherby spearheaded the Vandenberg project, the first real shipwrecker of modern times. Well, the Vandenberg went down last May, and we've had a real interest in scientists as to how artificial reefs really function. Do they really make more fish biomass, or do they simply attract fish from adjacent reefs? That's been a long-standing question to scientists. But since we study harmful algal blooms, we had heard reports of all this algae growing on the satellite tracking dishes on the Vandenberg that you can see here. So this particular video was shot in August, okay, during the rainy season when nutrients do tend to go up in the water. A lot of this algae is red, large red algae and green algae. You can see some of it here. Now this was shot by a colleague, Tom Jackson, in Key West, and he said, Brian, you got to get down here and see this. You won't believe all the algae that's growing on the Vandenberg. And I said, well, send me some pictures. So I know what it is, and he sent me some little video clips, but couldn't quite identify them, so we ended up obviously having to go down there ourselves. So one of the real concerns with artificial reefs are invasive species coming in, say, from the Pacific Ocean, something that could take over, kind of like the lionfish that's becoming a real problem in the Keys. So we didn't get down until November. This is our film now that we shot, and by the time we got down, unfortunately, Hurricane Ida had passed a week or two just before we got there and had scoured the Vandenberg of all that large algae. However, we did get to see a lot of recruitment going on of sea urchins like Diadema, this black urchin here, and all the algal turf, all this green filamentous algae that forms a thick carpet all over the steel plating on the hull of the ship. This, of course, is food for herbivores such as sea urchins or parrotfish, and even cyanobacterial blooms, this red patch. We went down, penetrated the elevator shafts that go down inside the hull. Of course, not a lot of light gets down here, so you don't tend to find as much algae down in the innards of these artificial reefs. So we're heading back up. We got down to about 130 feet depth and went back out to the satellite dishes. And of course, these are up in relatively shallow water. Most of that big algae was gone, but we found these little plants of Dictyota, these brown algae that were growing in a kind of a turf on these satellite dishes. So Chip, my assistant here, we're photographing and collecting it for chemical analysis. And you do have to kind of watch your time. And so we're on our way up here, headed to Duval Street. Gonna go have a mojito, and so I'm going to my safety stop, and we're here. Chip is watching the time, and he finally says, "Okay, let's go." So the one interesting thing about the Vandenberg is the Swiss cheesing. We didn't really get to see much of that in the video, but it allows divers to penetrate into the between the bulkheads of the hull. And as I pointed out, these satellite dishes do come up to about 40 feet of the surface. And that's where, of course, you get a lot of light up there, and that's where we've seen a lot of these algae blooms occurring. One comment on the use of artificial reefs from Jim Bonsack's work back in the 80s. He wrote a nice review paper of artificial reefs. And I thought this was very interesting, that artificial reefs are good tools to achieve ecosystem enhancement, but are not intended as replacement for maintaining water quality and must be used in conjunction with sound resource management. So again, this water quality issue we've known about for a long time. And it's very interesting that after the Vandenberg went down, there was about 3 weeks to a month where we had very low visibility, 5 to 10 foot visibility, way out there, 7 miles off Key West and 140 feet of water. Which brings us to the next part in the final chapter of this talk about monitoring the health of these waters and where all this dirty water is coming from. Obviously, it's still a big issue, even with these artificial reefs. Now, the idea, of course, of working with NASA has been great. It's something I've wanted to do for a long time. But a lot of oceanographers and ocean scientists, I think some of you know, have been very critical of the space program, of all that money going to explore outer space when we know so little about inner space, our own oceans. It's interesting that Jacques Cousteau was an exception to that he realized satellites were the only way to monitor the health of the oceans. And Stuart Brand of the Whole Earth Catalog recently pointed that out in his new book. And so some of this technology that we're using today are these new satellites, the Modus Aqua and Modus Terra, that are really giving high quality images of the region here in Southwest Florida. For example, the Blackwater events that have been in the media a lot since 2002 or so, we can see these very clearly in Modus imagery, okay, enhanced color imagery. This one coming out of Charlotte Harbor, a release from the Caloosahatchee in October of 2003, streaming down towards the Dry Tortugas out here. Here's the Marquesas in Key West. Okay, another event in 2002, this Blackwater is associated with Shark River Slough, which we've been talking about tonight. It's right in the hip pocket of Florida Bay and the Florida Keys. This one we know caused a lot of resource damage. Just one event. A lot of the divers and the Coral Reef Monitoring Program in the Keys recorded kind of before and after photos of reef corals showing the loss. This is July 2001 before that event, and then August 2002 after the event, living coral shifting to algae. In this case, this is Lingbia algae, okay, that's cyanobacteria. So we know these can be very destructive events. The other thing we're going to be looking at in this research is being able to distinguish between what we call CDOM, or colored dissolved organic matter, this black water mass. These are compounds in water very similar to tea. Okay, when you make a cup of tea, they're pigment-like compounds in the water that absorb light. But in that mass of black water, there's actually an algae bloom of red tide. But we have to use this fluorescent line height algorithm in order to see the algae within that black water mass. So we're going to be going back through time to reconstruct a lot of the harmful algal blooms and their linkages to the runoff from both Shark River and the Caloosahatchee. Also going to be looking at this fluorescent line height data, trying to see truth it. One of the problems is this a bloom of phytoplankton in the water, or is it a bloom of macroalgae on the bottom? This particular image, it turns out, it's macroalgae on the bottom, okay? We happened to be there when that was happening. But if you're not on the ground, oftentimes you can misinterpret these images. So what we hope to do is really help the Gulf of Mexico Alliance. All the Gulf of Mexico states have agreed after Hurricane Katrina, all the hurricane runoff here in Florida in 04 and 05, that we have to reduce nutrient loading to the Gulf of Mexico. We don't want to ever see again all those dead zones lined up throughout the Gulf region. And so it's NASA's intent to provide assistance to both the EPA and the Florida Department of Environmental Protection. These are a lot of the different products that we're going to be preparing in this study to help in this process. And the bottom line here is helping these agencies actually establish these numerical nutrient standards and thresholds. We're actually going to be having a meeting right here at Harbor Ranch in about a month to be part of this process. And with that, I'd just like to close and thank some of my collaborators who have made a lot of this work possible. Charlie Yench up here, the founder of the Bigelow Lab up in Booth Bay Harbor, Maine. He is retired now, lives on Duval Street in Key West. So that's who I drink martinis with when I go down there. Sandy Shumway, the editor of the Journal Harmful Algae and Journal of Shellfish Research, both been great collaborators in all this work. Chip Baumberger, Brad Bedford, my research assistant.